So the purpose of this investigation is to find out or to answer these two questions. So the first question is, how does adding or subtracting a constant affect the mean and standard deviation? And the second question is, how does multiplying and dividing a constant affect the mean and standard deviation? So to do this, we are going to use a spreadsheet, um, which is here. Now, in this spreadsheet, we have some data points. And what I will do is basically to either add, subtract, multiply, or divide uh, a constant number uh, from each of these data points. So each of the data points will be affected. That's basically what I mean in this case. So first of all, let's start by looking at the effect of adding a constant to each of the data points. So suppose I add 3 to each of these data points. We can see that the original mean was 6, but now the new mean is 9, which means that 3 has been added to the original mean to end up with 9. The original standard deviation was 3, the new standard deviation is 3. So the standard deviation has not been affected. It's only the mean that has been affected. Okay. Remember, again, this is the original mean and standard deviation. So suppose I add something like 5 to each of the data points. Again, we can see that the mean is 6 plus 5, which is now 11, but the standard deviation is still the same. So the standard deviation is not affected, but the mean is affected, of course, by adding the constant. Um, how about if I subtract? So suppose we subtract 6 from each of these data points. Again, of course, you can see that the mean is 0. Yeah. So, which is basically 6 minus 6, which is 0. But the standard deviation is still 3. So standard deviation is not affected. It's only the mean that has been affected. Um, so that's a really good observation. So basically we can see that if you add a constant value k to all the data points in a set, the mean increases by k, but the standard deviation remains the same. So let's now look at the effect of multiplying a constant to each of the data points. So suppose we multiply each of the data points by 2. Obviously, we can see here that the mean has changed. It was originally 6, and now it's 12. Remember, 6 multiplied by 2 is 12. So the mean has been multiplied by the multiplier to end up with a new mean. The original mean has been multiplied by the multiplier to end up with a new mean. The standard deviation has also changed. The original standard deviation was 3, but now it's 6. Now, what has happened here is that the original standard deviation has been multiplied by the constant, which is 2, to end up with 6. So this is, again, the original data set. How about if I have something like a multiplier like 5? Again, we can see that the new mean is 30, and that's as a result of multiplying the original mean, which was 6, by 5 to end up with 30. The new standard deviation is 15, and that is as a result of multiplying the original standard deviation, which was 3, multiplied by 5. Again, here's the new original data set. How about if I had something like negative 3? So multiplying by a negative. We can see that the new mean is negative, which is negative 18, which is a result of multiplying the original mean, which is 3, by negative 3 to end up with negative 18. But the standard deviation is 9, which means that the new standard deviation is the original standard deviation, which is 3, multiplied by the modulus of negative 3 to end up with 9. Yeah, so we can say that if you multiply all the numbers in a set by a positive value k, Both the mean and the standard deviation are multiplied by k. But if k is negative, the mean is multiplied by k, but the standard deviation is multiplied by negative k. Yeah? So we can make those conclusions here. So these are the observations from the investigation, and I've already explained all this.